Okay, so we're going to have a look now at scientific notation and what that's about. Just a quick definition here. Scientific notation is used to represent very large. You notice that I've used very large font there, or very small numbers. So numbers that are too big for our calculators or too small for our calculators to show on our 12-digit screen, or just too big or small just to write down. Really, we use scientific notation for that. So let's look at some examples of scientific notation, where scientific notation is appropriate. So we have, here's a good example, a scientific one. 1 times 10 to the power of 14 cells, I believe, in our body. It's quite a few cells. So what this means is 10 to the power of 14. You know what that means? That's 10. That's like a 1 with 14 zeros after it. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that was helpful, wasn't it? Get rid of that now. You understand what that's about. 1 times. Okay, what's some more examples? That's a large number. The population. What's the population of the world? Well, population of the world is 7 billion, thereabouts. Or we could write that as 7 times 10 to the power of 9. So 7 billion in words, that works. This is in using digits, without having to go to 9 zeros. So that's the idea there. But yeah, that's doable, isn't it? It's sort of on the edge of doable, that one. Distance, the distance, what about the distance from, so if we're talking about distances in space, which are great examples here because they're so enormous. The distance from, oh, we're learning some stuff here too, aren't we? From Earth to the Sun, which makes this place inhabitable, is, what's that, 1.49. I'm just taking this off the top of my head, because I've got this stuff in my head already. 1.49 by 10 to the 8 kilometers. Okay, so how would we write that if we needed to, as a number? So 1.49 times 10 to the 8. This 10 to the 8 means take this decimal place and move it. Shift it 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. So to approximate, I'd fill with zeros here, and that's what it would look like. Get rid of that decimal place, and that's what the digit would look like. Sorry, the number would look like 1, 0, break it up like that. 149 million kilometers would be that distance with that number there, 1.49 by 10 to the 8. Okay, I keep rubbing these out. That's okay. Let's think of a couple more. All right, what's just a small example. The mass. All right, here we are. The mass of an electron, which is just a little particle in a cell, tiny. The mass of an electron is, check this out, 9.109 by 10 to the power of minus 28 grams. 1 gram is tiny, tiny, tiny. You know what 1 gram is. This is 9. Alright, so what's this number look like? 9.109. 10 to the minus 28 says take this decimal point and go left 28 spots. 1, 2, 3, 4, 5, 6, 7, 8. Don't make me do it. That's 28 spaces back here, which means I would have about 27 zeros. So 0.27 zeros, 910, that's a small number. Right, you get the idea. Scientific notation used for very large, very small numbers. Okay, significant figures in a digit. We'll have a look at an example here. But significant figures also come into play when we talk about scientific notation. So that'll come up in an example here in a moment, I feel. So I'll take a look at some examples from the textbook. So write this. So write as a, here we go. Write as a basic numeral. So a basic numeral. Right, write these numbers as basic numerals. So let's go back in here, a 5.016 times 10 to the power of 5. So you would go, okay, right, this is basic numeral, so I've got to convert it from scientific form, scientific notation, into a basic numeral. So I'm going to take this decimal point and go 1, 2, 3, and then I'm going to get 2 more, 1, 2. I'm going to put zeros in there. So I've got 501600 would be my conversion. So 501,600. There's another one here, 3.2 by 10 to the minus 7. 3.2 times 10 to the power of minus 7. So I'm going to go 7 back here, 1, 2. Now what that tells me is that I'm going to be going 0. What would happen here? Zeros go in. I've got 1. 0 goes in there. So I've got how many zeros? 6 zeros before the 3. 1, 2, 3, 4, 5, 6, 3, 2. Let's just check that. Take this number now and go 7 to the right. 1, 2, 3, 4, 5, 6, 7. It's back where it started, 3.2 times 10 to the minus 7. Okay, let's go the other way. Write these numbers in scientific notation using 3 significant figures. So, another example, and we'll just write these in scientific notation using 3 significant figures, or 3 significant figures. Now, if you haven't seen this significant figures before, this is another way of rounding numbers. You've probably know how to round to so many decimal places. You can also be asked to round to so many significant figures. Let's have a look at this. So the first number is 5,218,300. So 5,218,300. I like using commas to separate. That in scientific notation, this is how we write it. I didn't go through this up here before, but numbers in scientific notation have to be written. The rule is that there have to be a number here between 1 and 10 multiplied by a power of 10. This number here is always between 1 and 10. Okay, and it's multiplied by a power of 10. So this number in scientific notation would be 5. The decimal point has to go in there. It can't go there because that would be less than 1. It can't go there because that would be more than 10. So between 1 and 10, so it's got to go between the first 2 non-zero digits. So 5.2 times 10 to the power, I'm going to need to write some more digits out here. And this is where the scientific the significant figures, comes in. 3 significant figures. So what we do when we write in scientific notation, every digit here that I write down between 1 and 10, every digit is significant. So 5.2, so that's first significant, second significant figure. This is the third significant figure. Now, do I write a 1 or a 2? So I go to the next digit, the 8. That says round this 1 up to a 2. So it's 5.22 to 3 significant figures times 1, 2, 3, 4, 5, 6 to get it back to where it was in the question. So look at this. This is 3 significant figures. We've rounded this number off to 3 significant figures using scientific notation. So I've sort of come up with 2 concepts there. We'll just do another example. 0.0040. 42031. Now I'm going to write this in scientific notation. Where's the decimal point got to go? I've got to put it there between the 4 and the 2. So I go 4.2. I've got to stop at 3 significant figures. These are significant. The next one is also significant. It's a 0. So I go to the next one to see whether it holds at 0 or goes up. The 3 says it holds at 0. So 4.20 times 10. Now I've moved the decimal point there to write it in scientific form. I now need to move it back. So this number here, this power of 10, needs to represent how many spaces to go back to where it was originally. So I moved it there. It's now going to go 1, 2, 3 to go back. So 10 to the minus 3 is that number in scientific notation to 3 significant figures. Okay, so the point about significant figures is that it's every digit, when you write in scientific notation, every digit in this number here is significant. So if I was looking at, so 3 significant digits there, 3 here. Up in this case here, I had 1, 2, 3, 4 significant digits, and in this example here, 3.2, I got 2 significant digits. So that's the rounding off process. Okay, so we're ready now to do exercise 3H on Monday in class. So I'll see you then. Cheers.